Why would they be shaped like a pancake? Well, maybe they're spinning really, 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 really fast, and they get squished down that way. And that was the 19th century view of the moons of Jupiter. I'm going, where in the world did that come from? So they've got this kind of wrong idea about their brightness, but they've got the size right, and they've got the mass right. And if I look at any textbook through the 19th century, I'll find beautiful tables with the lists of the names of the moons, and their masses, and their sizes, and that's it. Nobody in the 19th century thought to take the mass and divide it by the size to come up with the density. Because until the time of Schiaparelli, nobody asked the question, what were the moons? They only wanted to know where were the moons. They had all the clues they needed, and they never used them. Well, there's one exception, a fellow who actually did do this calculation, and the calculation is completely wrong. I take his size, and I take his mass, and when I divide the one by the other, I don't get his density. In fact, the density that he came up with was 1/10 the density of water. There isn't anything in nature with 1/10 the density of water. You can have things way less dense if they're made out of gas, or way more dense if they're made out of iron, but there isn't anything that's 1/10. Thing that we try to tell our physics students, after you do a calculation, look at the answer and say, does this make sense or did I screw up? And he didn't do that. He didn't even try to guess what would have a density of 1/10. And he's the only one who did this. So for, up until the end of the 19th century, they have all the numbers and they're not using it because they're not asking the right question. Finally, in 1890, a fellow at Harvard College, Pickering, has a new way of measuring the brightness where he's looking only at the moon with a specially constructed gizmo inside his telescope, and then a mirror that will bring a star nearby so he can compare their brightnesses. And he says, it's astonishing, I don't see the brightnesses varying. I'm going, well, wait a minute, how did they actually measure the brightness in those days? They had somebody looking at the star and looking at the moon with the human eye and comparing with the human eye that they look alike. And generally, this is a very accurate thing to do because the human eye is pretty good at comparing brightnesses. Unless, of course, the moon you're looking at happens to be right next to incredibly bright Jupiter. Because your eye is going to shrink down to compensate for the brightness of Jupiter, and suddenly the moon next to Jupiter is going to look really dim. And then you're going to publish that Jupiter's moon got really dim, which only proves, of course, that you were really dim. Finally, Pickering shows that they are bright and they stay bright. Not only that, but Pickering shows that if you know the brightness and the size, and you know the mass, you can come up with a density, and the density is about half the density of rock. Finally, he gets that right. So he's got the brightness right, and he's got the density right. And he says, what could it be that is made up with this brightness and this density? He says, well, one possibility is that it's a planet covered with white clouds, but these planets, these moons, are so small that it seems very unlikely. Quite true. He says the other possibility is that the moons are made of piles of white sand. And that would explain why they go so flat when they spin. Forgetting that now that he's shown they don't change brightness, they don't have to be flat anymore. So close, so wrong. It isn't until the 20th century that somebody finally works out that they're made of ice. I finally find a paper in 1925 a fellow named Jeffries. Jeffries is trying to figure out what are the planets in the outer solar system made of. And he sees the mass of Jupiter, and he sees the size of Jupiter, and he puts the two together, and he shows that the density of Jupiter is about the same as the density of water. And he then concludes, completely wrongly, that Jupiter must be a big pile of water. He forgets that something as big as Jupiter is going to compress the material into the center to a much higher density than you would expect. He completely neglects this. But he does argue that Jupiter being made out of water isn't so crazy because, after all, everybody knows the moons are made of ice. They do? He doesn't bother citing anybody. It's just that it was so obvious to him, he assumed everybody else already knew it. My own expedition into the moons of Jupiter, the master's thesis, started out with the idea that they're made of rock and ice. And I know that every rock has a tiny bit of radioactive materials in it, which will decay, which will give off heat. Would there be enough heat over the 4.5 billion years that these moons are out there in order to cause the ice to melt? Well, this is a calculation. You can count up how fast is the heat building up, how fast does the heat get out, does the heat build up fast enough to get to the melting point? My deck of computer cards was that thick. This was 1974. But I did the models, and I showed, sure enough, it should happen that Europa will melt. And when the water ice melts, the rocks will fall to the center, the water will squirt out to the surface is going to stay cold, so it will be icy crusty, and you'll have an ocean in between. And my little science fiction mind goes, all of that water has been percolating up through the rocks, and the rocks probably have carbon and other interesting things, and it's, like salt water, and it's going to be nice warm temperature because it's melted. Could you have organic chemistry going on there? Could you have life going on there? Could you have little fishes going on there? The very first scientific paper I ever gave, 1975, at the University of Arizona on a big meeting about Jupiter, and I got up to present the results of my master's thesis. And the chair of that session, introducing me to the world, was Carl Sagan. Oh. Carl Sagan, who loved the idea of finding life elsewhere. And so before the talk, I'm about to announce this and then sort of add at the end this cool little idea. And I said, Carl, what about, I have to warn you, I had actually written in my thesis about the possibility of life, but being a smart alecky 22-year-old, I didn't say maybe there's life. I said maybe there's organic chemistry, but I will leave the prediction of life to someone else more experienced in these speculations than I am. Thinking of Carl Sagan. So, of course, this means I am not the first person to predict life in the oceans of Europa. I'm the first person to specifically not predict life in the oceans of Europa. But I tell Carl about this because I figure he's going to be really excited. And he looks at me and he goes, how thick was that crust again? Oh, 50, 100 kilometers of ice. And he goes, where is the life going to get its energy to live? It's going to be pitch dark down there. There won't be any sunshine. Life as we know it depends on sunshine. And I go, oh, rats. And so I don't announce it at the meeting and I don't include it in the paper. 5 years later, they discover ice in the darkest, or they discover life in the darkest parts of the ocean. And it gets its energy from volcanic plumes, not from sunlight. And one of Carl Sagan's students publishes this idea of maybe life here. Almost correct. I didn't have the courage to be wrong. But it did make me think of one thing. Imagine, if you will, Europa, a moon of Jupiter, with a rocky core, a liquid ocean over the core, and a crystalline sphere of ice, much like the crystalline spheres that the ancient Greeks talked about. Imagine, if you will, an intelligent tuna swimming through these oceans, never knowing that the universe didn't have a bottom and a top, because the only universe it could ever experience would have a bottom and a top. Until maybe, one day, a giant impact occurs, cracks through the shell, and the tuna is swept up in a current of water to see, through the ice crust, the rest of the universe. And it's full of stars. Thank you very much.
I believe we have time for some questions, and I think the folks at the library have set up a microphone, this Paul Burns over there, with some questions. So if you have a question, I think you need to go over that way.
And line up in front of the microphone so we can hear you. So. All right, we got a few takers here. Go right ahead. First come, first serve. And if I refuse to answer your question, I'll let you know.
Have you looked through the Hubble Space Telescope before?
I've never used the Hubble myself. I have to remind you that no one looks through telescopes anymore. Because though the human eye is better than any piece of photographic plate, it's not better than a CCD chip. For one thing, it's unrepeatable. What I see may not be what he sees, but when you have the mechanical computer chip collecting the light, we can both look at the data at the same time. I've never used Hubble, but I have worked with people who have used it. I have used the largest telescope in the world right now, which is the 10-meter Keck telescope. And there's an interesting story about that. I was given one night of Keck telescope time, flew out to Hawaii. The telescope is at 15,000 feet, so you don't actually go to the telescope. You go from a little control room in a small village halfway up the mountain. So I got to the control room in the small village, told them we wanted to use the telescope through a high-speed computer line. And the people at the top of the mountain said, sorry, it's snowing up here tonight. Snowing in Hawaii. So I went back, went to bed, my one night done. Got up in the morning and realized it's Sunday morning. And I'm a good Catholic boy. And there's a church in town. So I go to church. And as the pastor is greeting all of the different visitors and asking where you're from, and he goes, one, California, oh, you're from Ohio, you're from Kentucky. And when he gets to me, I just say, well, I'm an observer from the Vatican.
Dr. Father Brother, is there intelligent life, as we understand intelligent life, out there somewhere? And if so, what is their relationship with Jesus Christ? Or do they have the same relationship with Jesus Christ that we do on this earth?
In other words, would you baptize an extraterrestrial?